Hi, everyone. Can anyone hear me? Yes. OK. My name is Antonio Andrade, and today I'm going to be presenting to you some work that I've done on top of Datomic. The title of the talk is Building a Data Platform with Datomic. So the first thing I should say is, what exactly do I mean by a data platform? And what I mean is a software system that defines a data representation and abstracts its persistence and retrieval, and provides tools to manipulate the data. So in this diagram, where blocks represent either consumers or producers, you have the hardware at the very lowest level, providing services to the operating system, and the operating system providing other services and tools to higher level layers. So the talk is going to be mostly focused on those two layers, the database layer and what I call the infrastructure code layer, which some people call code libraries or frameworks or whatever code people, senior people in your company write for other application developers to consume. So that's what I'm going to be talking about. And so first of all, I'm going to introduce myself. I'm a software architect at Appian. Appian is a software company headquartered in Reston, not too far from here. And what we do is we have a software platform that let other people build and configure applications and then run those applications on top of that platform. When a company wants to buy software, they have three main options. One is to build the software themselves. If they have an IT department, maybe they can do it. Second one is maybe they want to hire a consultancy company to build a product for them, right? The third option, and the option that Appian provides, is we give you the tools, we give you an application platform for you to build applications, design applications on top of it. So our customers build their own apps, and they design their own data models on top of the platform. Now, the system is highly dynamic, as you can imagine, and most of the configuration and things that we do happen at runtime, which means that we cannot make too many modeling decisions beforehand. We do not know what our customers are going to use our platform for. We have customers in health insurance, financial applications, commercials, and government agencies. So that's the challenge. And so you may wonder where Appian gets all this power from. And I'm going to try to describe it really fast. Appian is a transactional system. It has a very rich data model. It supports arbitrary tree structures, not like Datomic, which supports an EAVT schema. We have a very strong data manipulation and query language, which is a variant of APL. Mike Anderson was talking about a core matrix yesterday. He was talking about APL. And we use a language called K, which is a variant of APL. It's an array processing language. So we get the power of the data manipulation and query from there. Datomic gets it from data log, mainly. Now, data consistency means we can also issue multiple queries on a single data snapshot, which means the programming model that we follow is very similar to the one that Datomic provides you. Now, Datomic gives you this through immutability. Right? If you make a query to the database and you want to keep making queries to the database and make sure that all those queries are looking at a consistent snapshot, you can do it because of immutability. We don't do it through immutability, but we have the same programming model, which is very powerful. Then we have performance. We use a high-speed in-memory column-oriented data store. And we also provide an embedded programming language in the platform. So a lot of the similarities between the Appian platform and some of the characteristics of Datomic. And that's the point of the talk. So what I'm going to try to do is use my experience and expertise on this type of system and try to describe to you how would I build a similar system using what Datomic provides. Right, so we're going to focus a lot on the data model, and this is the roadmap. So we're going to talk about schemas and data models. Then we're going to look a little bit at the Datomic data model. Then we're going to go very deep into a way that you can use or design to generate a schema that is self-described. And this is very important because it doesn't necessarily apply to Datomic, but you can take a lot of this input and use it on your own projects. We're going to see some techniques for doing data versioning and migration, data constraints enforcement, and then what it means for Datomic to have a reified transactions. Okay, so first of all, what is a data model? A data model, I think, is a conceptual thing. Every system has a data model, whether or not it's explicitly defined or it's implicit on the data that is being recorded in the data store. But the data model exists regardless. And it just describes the structure of the objects on those systems and the relationship between those objects. Now, regardless of what everyone may think about schemas, I think data models have really powerful, or provide a really powerful communication tool and documentation. And a schema is a way to represent these data models. So I talked a little bit about Appian, and if there's something that I would like you to take from this talk is that I think data models are at the core of data platforms. If you get your data model wrong, then so this is a real photo of an oil platform. It's in the Norwegian Sea, and it's called Dragon. And when I look at software systems, I sometimes like to look at this picture, and that's your data model. What I call a data platform is that thing that is on top of that data model. And the rest of the application code is what you see on top. Now, if you're working at the application code level, it's really difficult to see the problems that you run into when you try to expand or make changes. Right? So it's not very cost effective to go and do something about that data model that was decided very early on. Right? There is not much room to build on top of this platform. Now, one thing I wanted to separate is a data model is a mental map of the object relationships on your system, which is separate from a physical schema that you may encounter whenever you're dealing with databases, right? So this is a messy, if you will, database schema, but it doesn't mean that the data model is not that messy. It only means that people don't like to be working with this kind of systems. But schemas are really good for performance. They are a great documentation tool, especially if you're working on a company that is bringing new people. The new hires really appreciate the fact that there is some way for them to figure out what the data model is, how to interact with the system. So it's great for documentation. It's good for enforcing data contracts, as we saw in a talk yesterday. And it is really good as a reflection API on very dynamic systems. It may seem counterintuitive, but I think, in my experience, the more dynamic a system is, the more important it becomes that you have a schema. It doesn't mean that it has to be, hard-coded. It just means that you pay more attention to it, because you can get a lot more information from what the system is doing at runtime, which otherwise you wouldn't get. And they're good for code generation. Yesterday, someone was talking about how they were generating code based on the schemas. We also do the same thing. We have native platforms or engines, iOS and Android and the web, and we for convenience, we can take those data models and generate static classes. Other people like to be working with, or some people like to be working with static typing, and it makes junior developers understand and the code faster and be more productive. But schemas are also really bad when the structure needs to change. So can you imagine wanting to change that or to do an upgrade? It's probably not going to be very easy. So the key on all this is adaptability, which is something that that I think that Datomic provides really well. And the key part here is that the application code is the one that should be deciding what the shape of the data is whenever we make queries to bring the data back from the backend. And so a system that requires live data migration to reshape the structure of the data or to reshard or to do other kind of stuff is not very adaptable. And I think that in general, if you're building a system like this, you should try to avoid building something on systems that only lets you make queries, efficient queries against data that was stored in a certain way. That's, I think, one of the disadvantages of document store or schemaless databases. They will let you put anything on the database. The problem is not storing the data. The problem is that whenever you want to retrieve the data, it's hard to get it in a different shape than the shape that it was put in. So let's jump into the Datomic data model. This is the basic API that you would use to install new datums into the system. And in this line, we're just requiring an API, and then we get a connection to the database. And we finally, with that connection, we can transact a bunch of datums. Well, datums a datum is a fact. It's a addition or retraction of a relation between an entity, an attribute, a value, and a transaction. So in this case, you can see that we can either add or retract facts, and we have to give an entity to the system, an attribute. In this case, we have an entity with an attribute called person name and person age, a value, and finally a transaction. Datomic doesn't show this initially, but what really happens is that every time you make a transaction, there is a new entity created in a partition called TX for transaction, which captures the instance of time in which those set of datums were stored in the database. So you can always get, from a transaction, you can always get all the datums that were added or retracted from the database, and given any entity, you can always know or find out which transaction that entity came from. That'll be very important later, as I'll explain. And there is a shorthand notation. This is important because I'm going to be showing a lot of these examples. So this and this are basically the same thing. We're transacting two datums. John, age 25. And the first key differentiator of Datomic is that attributes are facts or data, and you install them into the database just as you would install any other entity, attribute association. So here we are defining or installing an attribute. Attributes have a name, a type, and a cardinality, and you can install them on the fly. And something that people don't realize initially, I didn't understand this initially, but attributes have free associations with entity. You can create an entity that have, there's a person and has a car, top speed, and computer keyboard, which doesn't make any sense, right? But the idea is that the platform allows you to do this. And usually the convention is, if some entity has an association with a person, a slash name attribute, then that means that thing, that entity is a person. So, right? So those are conventions that we give when we work with Datomic to give types to these entities. The problem is that if I ask you what's the schema or what's the data model of this entity, I'm not sure. So what I'm going to show you next is a way to define a higher level schema that provides a reflective API on top of what Datomic provides. And this is, again, important if you're building a dynamic system where data model decisions don't happen when you code the application. They happen after you deploy it. And this is what we use at Appian. This is what the core data model looks like. It has DT stands for data type. We have a data type that represents the type of the entity, namespace and name mainly for these ambiguation purposes. This is usually driven by customer data. If the customer wants to name their data models, whatever they want, they can use these attributes. We have a parent attribute to create type hierarchies, a list and a component attributes to create multi-dimensional lists, and a fields attribute that represents what you think it is. So this DT attribute is more or less equivalent to a .get class that you would do in object-oriented programming, right? If you have any object, you can always get its class from calling that method. This is an analogy. And when an entity, when an entity contains an association with these attributes, I'm going to call it a typed entity, right? It has a type. That entity has a type. And you can think of it as if an entity doesn't have this attribute, it's analogous more or less to a map. And if it does, it's more or less analogous to a type, right? You can get information from it. Namespace is analogous to a class package name, and it's used mainly to resolve naming collisions. A name is a local name, more or less analogous to class.simple class name. Parent is analogous to get a superclass, and it's used for building data type hierarchies. List is used to support multi-dimensional values that are auto-generated at runtime, right? So the example below, you can see that Java arrays do not exist until you actually need to create them. Right? So the JVM creates new class definitions as you reference this array, multi-dimensional arrays. The same we're going to do here. A component which is the opposite. If you have a class, an array class, you can always get its item type by getting the component type. And the fields, which is what you imagine, the fields of the data type, right? The properties. So this is a summary of what we just looked at. It's the basic reflective API that Java gives you, just translated into Datomic attributes. Now, we're going to go through an example, and we're going to see how this is actually applied. Imagine you have, again, this person instance that we started with. It has a name and an age, right? Nothing tells you that those attributes are actually associations that are supposed to be bound to this instance. They're just there. So what would happen if we add an attribute association, right? If we add a hint that points back to some type information. Well, suddenly we have a typed entity, which gives us a little bit more information when we're dealing with this type of entities, right? But where is this being defined or constrained by? Well, if you define a person data type, which is nothing else than an entity with an attribute, a data type attribute, whose value is also the data type attribute. Right? So this represents both an entity and sort of a definition of a data type. We can see that we have a namespace and a name, just to name them, and then fields that represents what the instances of these data types are supposed to contain. And then here we go a layer above. We have a data type, which is a meta model. This is both an entity that represents a data type definition and an instance of itself. And that Datomic lets you do things like this is pretty cool. It's what actually makes, I think, the system, the data modeling in Datomic very, very powerful. So we're going to go through this analysis really quick. We have an ID attribute. That's the identifier in the system, right? That points to the attribute that we just defined. And I previously said that when that DT/DT attribute appears as a value, that means that the entity is a data type. So this is a data type. It has a namespace. And if you see here, the fields are defining its own structure. Right? So we have a namespace because the field says that instances of data type must have a namespace attribute. We have a name. We don't have parent, list, and component types, but it doesn't matter. And we have fields, which points back to the same entity. Right? So this is the definition of a meta model to work with data types. Now, this is a graphical representation. And number one, that's our person instance. It has an attribute, a data type attribute, pointing back to its person data type entity. That person data type entity, number two, has a fields attribute. Those fields attribute contains the definition of that instance, right? So it has a DT attribute, and name, and age, and a weight. And if you take that person data type and go back again, we reach the data type. And it's the same, it's the exact same model, which means that whenever you reach that meta model, you have a model that describes itself. Now, okay, so how do we use this? Well, we can start creating more complex or higher level data models. We can start defining data type hierarchies. If you have a data type and you have a parent attribute that points to another data type, then you can suddenly model type hierarchies. Here we assume that student school attribute was previously defined, nothing that we haven't seen. And here is the graphical representation of what we just modeled. You have a number one, a student instance, which has fields that are coming from both the person data type and the student data type. Right, so this is, so think for a second what this means. It means that if you have a student instance that would otherwise be a complete, it would otherwise be a map, right? You wouldn't necessarily know what the structure or the expected structure of that instance would be. Once you have this data type attribute, you can go back and look at what the definition of that student instance is supposed to be, which is really powerful. In the dynamic system, you really need these hints in order to either generate meaningful data for the ultimate user. Imagine, I don't know, you are creating a UI, an interface, and you start with a student instance, right? Well, if you're representing a form that's supposed to capture data, then how are you supposed to know what other fields you're going to show in the form for the end user to populate, right? You couldn't know unless you had a schema or a data model for that instance. So this is powerful. Now, those are data type hierarchies. Next, we have multi-dimensional values. And here we have two entities, one on the top that defines a few attributes. The component attribute points to the data type entity, and the list attribute on that entity points back to this entity. So this is showing that, well, this is necessary because Datomic provides bidirectional references. So this link between two entities, you really don't only have to model one relationship, but this is here for completeness. And this entity on the top is more or less analogous to a person array, if you will, if you're dealing with a person data type. But you can go even further than that and define a multidimensional person, linking the entity on the top that we're just creating with a new entity that creates that link between those. And this is the visual representation of what we just created. Let's start with number one. You create a simple data type. Then you generate an array type of that data type. And you can go up and generate multidimensional data types. And then for each number 3 and number 6 here, if you follow the reference from number 6 here, so you know that the value of these instances is going to have this shape, right? The shape of the data type that this instance is pointing to. And you can traverse that relationship to understand what the data looks like. So you can imagine, once you have this information, this type hints, then you can create functions or wrappers that, having arbitrarily nested data structures in Clojure, can actually go and immediately persist that data in the database. Datomic only provides like one layer of multidimensional values. Other than that, you have to build something yourself like this. One thing I think is maybe lacking from the Datomic data model is the notion of an any type or a variant type, which means you sometimes at design time, you don't know what the type of the data is going to end up being. And Datomic provides all the primitive types and reference types. But other than that, it doesn't provide choice groups or unions for you to say, okay, this attribute is going to be either a string or a reference. There are some times where you actually need to do that. So this is a way to get around that, which is a little painful, but the idea here is you define an attribute and then a bunch of, we call them enumeration values, or a bunch of other attributes, actually, that represent every single type that you can hit in the system. Actually, there are not that many. All the primitive types plus the reference, right? So in the okay, it's not working. But you can see the dots in the bottom. That means that you have to replicate that attribute for each of the known data types to Datomic. And the definition, according to our type system or schema system, would look like this, right? You would have a data type called any, and its fields would be any of the known data types for Datomic, and you would need to make sure that at runtime only one of them is populated. Otherwise, it wouldn't make sense, right? And something related to this is the concept of typed references. In Datomic, if you have a reference, you don't know what that thing is actually pointing to. You only know that it's an entity, but you don't know necessarily what the type of that entity is. So because attributes are facts and data, and you can associate attributes with attributes themselves, you can add type hints here to say that this specific reference is of this type, right? Is of type any, is a variant type. And the diagram, again, looks something like this, where that person metadata on green is really a pointer to a bunch of any instances. And they can, this is analogous, I guess, if you will, to the metadata support for in Clojure. So you can have any arbitrary data structures attached to an entity. So this is a way to do this in Datomic. Now, that's only one of our problems. The other problems are much more difficult to solve. One of them is data versioning and schema changes. So for a second, we're going to pretend that we have a data type version 2 for person, and we are going to add an additional field, person weight. And this really means that this attribute is an optional attribute, and all the existing person instances in the database are still valid. They just don't have that value. That's fine. The problem really happens when you have, well, you can see this as an automatic migration, like adding a table to a column to a table. Everything is nulled out. No problem there, right? But there are other cases where you need to make other changes to the schema that do affect existing instances. So imagine that you need to add a health insurance attribute to that person entity, and you want to make that mandatory. Well, the problem is that whenever you add that health insurance attribute to the person, that is no longer optional, like in our system, and which means that existing person instances are no longer valid. Datomic is not going to do anything. It's not going to crash or anything, but it just means that our intended meaning has been violated, because now there are persons in the database that have no insurance. Well, how do we fix it? Well, there is a very powerful tool in Datomic, and that's the ability for you to persist or use database functions. Just as you can add an attribute of type string, you can add an attribute of type function. And you can have that function receive a database and the entity that you want to modify, and then generate whatever information you need to make, in this case, a person instance a valid one. So the idea here is that you or someone would define how to take something, an instance of something that is invalid and then make it valid. In this case, we're just hard coding the health insurance to something just to make it valid. But you can imagine that you could, if you initially model a person's name, first name, last name, and then suddenly you realize that you really didn't want to do that, and you want to create a single one, full name, let's say. For some reason, then you could write a migration function that would do that for you. And the whole point is that this type of attributes are just like any other attribute in the system. And then your application could take this information and do something about new entities being transacted in the system that violate this constraint, right? You could run this migration to set the data to a valid state again. Well, the problem is, when do you decide to validate and how do you decide to do it? You can, every time you, in this model, every time you add a required attribute, you must also specify a migration function. Otherwise, there wouldn't be any default value to assign to all the instances. And what you can do also is enforce that new entities created contain this required attribute. And how would you do that? Well, you would write your own transact function that is wrapping the original, and that it would do these checks. Now, the biggest problem is to decide when to migrate. You could potentially do the migration on the fly at query time. Imagine you have a query that returns a bunch of persons, and your application code is depending on the fact that they have a health insurance. So what do? Do you code that logic on your application code to make sure that it doesn't fail? Well, you could do that, but the point is that you could do it at, you could run this migration function at query time, but in this case, Datomic doesn't let you use migration database functions, as I showed you, as rules in queries, so it would be more complicated than that. You could fix the data at migration time, but if you made queries, they could return invalid data. You could do the migration every time you ask for an attribute, right? If you have an abstraction on top of Datomic and someone asks for a person's health insurance, at that moment you can figure out that, okay, so that instance doesn't have a health insurance, and you could use the the database function to calculate it. You could also use a background processing tasks, but that would only eventually eventually fix your instances in the database, or you could, last resort, you could manually do it in application code. The point is that these hints, this information are there for someone to take an action on them. One way to enforce arbitrary data constraints is to use these same database functions. This is an example of an enumeration in Datomic. You have a person, gender, and then you have two entities that represent female and male, which means that right now in Datomic you could do this. You could add a person, gender, and map it to something completely arbitrary, right? That will work. There's no problem with it. But how do you fix it? If you really want to make sure that that doesn't happen in your system, well, you write a database function. I'm not going to go through this, but this is a function that, giving a new value, make sure that that falls into one of the valid constraints. So you have to, whenever you define database functions, you have to give it a name. You have to add some information. And when the entities are being transacted, you have to look them up, look the correct values on the database, and fail the transaction if that doesn't match. And here, you could use the exact same syntax, almost, using the add foreign key function, and this will make sure that that transaction would fail. Last, I want to talk very briefly about reified transactions, which is the ability to attach information to the transactions themselves. Imagine you have an audit trail, or you require another trail where you have to retract, where you have someone retracting information from the database. Well, you probably want to know who did that, right? So you can instrument the code to add additional information to the transaction. In this case, it gives you back the username that is performing the operation, and it keeps an audit trail of, in this case, which retracted that information, and you can add a lot of more information to it. I think that's it. Thank you very much.